In this video you will learn how to quickly set up Yolo model in Python to do object detection. Prerequisite for this video is to have Python installed. You will see how to create a virtual environment and install needed libraries to do object detection. In particular, we will use Yolo 9C model. The Yolo, you only look once, model is a state-of-the-art object detection algorithm introduced in 2015. Yolo is used in various applications, including surveillance, autonomous vehicles, medical, retail, sports analytics. The main step of the algorithm could be summarized as follows. During the years it has been gradually improved, therefore we're going to see just the principle of the algorithm. Yolo divides the input image into a grid of cells. Each cell is responsible for predicting bounding boxes and class probabilities. The grid size determines the granularity of object detection. Smaller grids lead to more accurate localization but slower processing. Each cell predicts multiple bounding boxes, usually 2 or 3. These bounding boxes represent potential object locations. For each bounding box, Yolo predicts bounding box coordinates, the center, x, y, and width and height relative to the cell size. Object score, a confidence score indicating whether an object is present in the box. Class probabilities, probabilities for different object classes. After prediction, Yolo applies NMS, non-maximum suppression, to remove duplicate detections. NMS keeps the highest confidence bounding box for each object, discarding overlapping boxes. Yolo v9 marks an important step forward in real-time object detection, introducing groundbreaking techniques such as programmable gradient information, PGI, and the Generalized Efficient Layer Aggregation Network, GELAN. This model demonstrates remarkable improvements in efficiency, accuracy, and adaptability, setting new benchmarks on the MS COCO dataset. In the next part of this video we're going to work on a Jupyter notebook where we applied Yolo model for object detection. Let's first create a Python environment and install needed packages. To create a Python env, Python env. Before installing libraries, you'll need to activate the virtual environment. Let's then install the following Python packages: Ultralytics, Pillow, Matplotlib. After that, if we want to use this env in Jupyter, you can add the env with ipkernel. Adding a new Jupyter kernel allows you to use different Python environments within Jupyter notebooks. This is particularly useful when you want to work with specific libraries or dependencies installed in a separate environment. Install ipkernel with pip install ipkernel. Use ipkernel to create a new kernel for your environment. Let's now open the notebook. In this notebook you will learn how to use Yolo model for object detection. Let's start by importing needed libraries. You also have the reference to the Ultralytics GitHub project that we will use to do object detection. Let's now build a Yolo v9c model from pre-trained weight. You can display model information by using info method. We will use one test image for object detection. Running the inference on the test image is super easy, you just need to pass the image path to the model. The output of the inference is a ultralytics.engine.results. This is a results object with attributes. Boxes, object containing detection bounding boxes. Keypoints, object containing detected keypoints for each object. Masks, object containing detection masks. Names, all existing objects that can be potentially detected by the model. OB, a 2D tensor of oriented bounding box coordinates for each detection. Orig_img, original image as a numpy array. Orig_shape, original image shape in, height, width, format. Path, path to the image file. Probs, object containing class probabilities for classification tasks. Save_dir, directory where to save the results. Speed, information about the processing. As you will observe for detection tasks as the one we're doing right now, some fields are set to none, because used for classification and segmentation tasks. Ultralytics library already implements a default method for plotting, as you will see in the next cell. It will show each predicted object and with which probability, going from 0 to 1, with 1 equals 100% probability. Moreover, each object will have a different color. In the next cell we're going to see how to interpret the result object to do a custom plotting. The function plot_results will iterate over each object detected with a confidence threshold higher than the specified value, take the corresponding bounding box and add it to the plot. We can observe as the model has detected with higher confidence the objects in the foreground. As for those in the distance, no objects were found. We have finished this introductory lesson on how to use the Yolo 9C module. We have learned how to quickly set up the Yolo 9C model to do object detection. See you soon in the next video.